Now that we know what functions are, we're going to start to learn about inverse functions. And inverse functions can be thought of as opposite. So in our definition here, the inverse function undoes the work of the original function. So for example, if f, a function, takes an input of 5, remembering that input is our x value. So if f takes an input of 5 and gives an output of 3, the y value, then the inverse takes that 3 as an input and outputs it back to 5. So here, in this example here, remembering that 5 is an x value, so that ordered pair there is 5 with an output of 3, the y value being 3. So the inverse of that, that's what this little -1 is there, that represents inverse. The inverse of that is exactly the opposite. It now has an x value of 3 and a y value of 5. So they're just switching places. Okay, so we'll keep going down here in our note. If 3, 5 is on the graph of f at x, then 5, 3 must be on the graph of the inverse of that. The inverse can be found by making the x and y switch places. That's the easiest way to say it without all the fancy words and definitions. Good thing to have in your notes there. So let's look at it by table of values as well. So if I had a table of values that look like this, 1, 2, 3, 4, and when x was 1, y was 4, x was 2, y was 5, 6, 7. So the inverse of that table of values is just swapping their places. They're just switching input and output places. So now my x is 4, my y is 1, my x is 5, my y is 2, 6 and 3, and then 7 and 4. Our next example down here shows us some ordered pairs for a function. So f at x has ordered pairs 1, 2, -3, 4, -7, -5, 9, and -12. So when it says here what is the inverse, then we just take our f at -1, x, and we write all of those in the opposite order now. 2, 1, 4, and -3, -5, -7, -12, and 9. The signs don't change place, just the order. And that's that example done. If it wants the domain and range of the function, then we can state that. We just need to be really careful that we realize whether it's asking for a function or inverse function. Okay, so the domain for the function has values 1, -3, -7, and 9. The range, always the y values. So our y values are 2, 4, -5, and 12. So if we're looking for the domain and range for the inverse, then we have to be careful that now the order is backwards. So here for the domain, it is 2, 4, -5, and 12. And the range is 1, -3, -7, and 9. So in the next question, it asks us what we notice about our answers between B and C. And all that happens is our domain became the range, and the range became the domain in the inverse. They switched places. The x became the y's, and the y's became the x's. So now if we look at the effects that this have on a graph, for example, let's look here at the graph f at x equals 2x plus 1. What we start to do when we need to graph is we build a table of values. With your x values, you can choose any x's that you want. So let's choose -2, -1, 0, 1, and 2. So we'll take our x's, our input, and put them into the equation. So when we have an input of -2, I'll do some rough work here for this one off to the side, and then we can just fill in our table of values. 2 times -2 plus 1. 2 times negative 2 is negative 4, plus 1 equals negative 3. So when x is negative 2, y is negative 3. When x is negative 1, y is negative 1. And then when x is 0, y is 1, 3, 3, and 5. So now we need to plot these on our graph here. We'll assume that every grid line is 1. So at negative 2 and negative 3, we'll put a point. And then at negative 1 and negative 1, so we're going to have 1 there. 0 and 1. 1 and 3. You can see we're already forming a perfect straight line there. 2 and 5. And then you would use your ruler. I'm going to do the best I can here. Form a straight line going through. And there we have it. I'm going to switch colors to show the inverse of that. So my table of values without having to calculate is quite easy because I just switch my input and output values. So now this is going to be negative 3 and negative 2. Negative 1, negative 1, 1 and 0, 3 and 1, and 5 and 2. And then we graph those the exact same way. I'm going to go over negative 3 and down negative 2, negative 1 and negative 1, 1 and 0, 3 and 1, right there. And last but not least, 5 and 2. Again, using a ruler, of course, we're going to join these to form a nice straight line. What we need to notice for further lessons is that, let's see if I can make this blue a third color on there, is that we have a reflection through the x equals y axis. And what we mean here when we say the x equals y axis, the x equals y axis is whatever the x value is, the y value is as well. So when x is 1, so is y. When x is 2, so is y. 3, 3. So that there happens, right, all the way through your middle points. All the way through your origin. This line here, this blue, is your y equals x line. So your x, your original function, has just been reflected over your y equals x line. And so sometimes that can make it easier to do the reflection rather than having to do calculations or two table of values. So we'll leave you with that for today, and then we'll do the practice questions in class tomorrow.